So now that we're doing word problems in quadratics, we're going to be taking a look at a couple of different ways that we can approach these questions and how we can kind of answer them in the context of it. I just want to kind of preface this by saying this is a lot of what grade 12s are going to be doing in terms of their polynomial unit and quadratics in grade 12 applied. And a lot of these questions have a lot of carryover to that as well. So what we're going to do today is also a lot of the techniques that we'll be doing in grade 12 when we come back to these questions, but use other functions as well, not just quadratics. So let's take a read of the question and see what we can do. Using 100 meters of fencing material, an area of a rectangular pen, A enclosed along a riverbank based on the width of the pen, W can be modeled by the function equation below. So a picture is not necessary, but a picture does maybe help us out in terms of what's going on. So I'll just kind of do a really rough sketch here. We'll kind of say that this is my river here, and we're going to build a rectangular enclosure around it. So something like this. So we don't have to put any fencing along the river here, but we do need to make sure that this fencing here, we only have 100 meters of it. So like kind of you can think of a perimeter is going to be 100 no matter what. And we know that the width of the pen, I'll just call width, I'll call width this here. This will be the width of the pen. Doesn't really matter what your picture looks like. However, this is fine. It gives us the equation. A is equal to negative 2 w squared plus 100 w. So we have here is our area is listed on this. You wouldn't have to make this equation unless you had a table or something like that. So they give you the equation. Awesome. What we're going to do is we're going to put this into Desmos, but again, we're going to have to make sure that Desmos actually knows what we're looking at. So we're going to have to substitute a y in for a, and of course, x squared in for w squared, and then just an x in for that. So let's go ahead and let's get Desmos out and let's put this in. So I have my Desmos open, and I'm just going to type in exactly what we just said. Okay, and as you can see on your Desmos graph, if we're looking at like the home view of it, we can't really see too much of it. So there's going to be a lot of things that we're going to be able to do here to kind of get the entire picture going on. So first off, I'm just going to go ahead and hide this expression by using this button here. And then we get to see this. So what I'm just going to do is keep on scrolling out until I get to something that I'm looking at. Well, I have these two lines, so I'm going to keep on going. Then I should see something way up here. Now, this is kind of crappy to look at. Look at all of this wasted x value space. In fact, if I push these two x-intercepts, I'm really only looking at intercepts between, or values between 0 and 50. And I need a y value all the way up at 1,250. So if you pick the little wrench icon, you get to actually set what your axes are going to be. So for my x-axis, it says, hey, we're going all the way from this negative 1,000, all that stuff. Let's just get rid of that. And let's put a value that's a little closer to our stuff. I'm going to put in negative 10. And for our maximum value, you can already see our graph changed, but for our maximum value, remember our other x-intercept was at 50, so I'm just going to go a little bit ahead of that and put in 60. Just doing this makes the graph look so much better. I think I'm actually just going to keep the graph like this, keep the y scale the same. And as you can see, Desmos does a great job of scaling everything for us. It's saying that these blocks are going up by 20, these blocks are going up by 500, and we get to what we're looking at. So pretty good. Let's kind of describe this a little bit though. I'm going to go ahead and I'm just going to get the things that we normally look at here. I think I might just zoom out just a little bit more. And I'm going to take a screen clip of this, or vice versa. What you guys can do is just copy this down for yourself and do a quick little sketch of it. So I'm going to go ahead and take this. I'll copy this down for myself, take Desmos away, and there we go. So I can kind of use this now. There's a couple things that we want to do in here. We want to make sure that we are looking at this graph the proper way. So I'm not 100% done with Desmos, and I'll show you a little bit of what I'm talking about just in a sec, but let's just kind of analyze what this graph even means in the first place. So first off, what this graph is meaning is if our y-coordinate is area, well then obviously our axis over here is going to be our area. So I'm just going to kind of label that on my graph that, hey, this axis is area. And that means this axis over here is width. Now I have a couple of points here, but there are a couple things that, if this question was just graph this function or the situation of this function, then we do have a problem, because this section over here is negative width and negative area. This section over here is positive width, of course, but it's still negative area. These things should not exist. So there is a way for you to get rid of them. First off, if you're doing this by hand, just don't draw these, right? That would be pretty much the easiest way for you to do this. If you wanted to quite literally copy everything that you see on Desmos, like I've done over here, then you're gonna have to go back into Desmos and just tell it that, hey, I don't want any of this stuff that's below. And we can do that the same way that we kind of handle the linear inequalities. It's much easier in this case. So I'm gonna go back into Desmos. I'm gonna go to my equation. And all I have to do afterwards is just say, hey, I only want positive y values. And that's going to take out both those things that we don't need. In braces, we're going to take brace. Y has to be greater than or equal to 0. If you wanted to do strictly greater than, that's okay too, because we wouldn't want an area of 0. And here we go. So we have kind of our oh no, I think I actually got rid of it. There we go, that's better. We have our graph here, and now you can see that it's very clearly no zeros, or no negative portions here and here. I'm just gonna keep on using the one that I have just for simplicity. So those should not exist. You can make a little note of it here. You can even just be like, kind of like that, and that would be okay. You wouldn't need to put any arrowheads because, of course, then that kind of defeats the purpose of us saying it should not exist. So what are we looking at? Well, we're looking at as the width increases, our area increases up to a certain maximum point, right? Up to a certain max, then it keeps on going back down. So I know this question doesn't actually have any questions asking in it, but there's some questions that we could ask. So something like this. One, what is the maximum area that the pen could have? Right? That's a very typical kind of question in terms of this. And we would say that the max area would be, of course, 1,250. It would be probably a good idea for us to make the units here in terms of meters squared. I think I'm just going to add that onto mine as well. This is area. I'm just going to label this out area. It's measured in meters squared, and it has the value of A. Down here, I'm going to have to kind of squeak it in a little bit. I'm just going to scroll down. This is going to be width. It's W, and it's measured in meters. Okay, so just so that we kind of make sure that we label out our axes. So that's our area. Of course, the follow-up question is, what width does this occur at? So maybe like, what width does this occur at? And we would just have to read the x coordinate here, so 25. So this would be width. I guess I'll do that in blue. Width equals 25 meters, right? So just kind of reading your graph. So kind of just interesting questions that we can ask for that. There wouldn't be really much more in terms of questions asked. I'll make up one other one. We can just say, hey, what's the domain and range of the situation? Or I'll just say the context. So again, we're reading our x values. I suppose we can assume that the area will be equal to 0. If it wouldn't be, then our inequalities would just change just a little bit. But for our case, we can say that the area could be 0 because those are our 2 points. So our domain in this case would be 0 less than equal to. We have to use our independent variable of w. We can't use x because it's of the context, and the context is width, right? So to 50. And range, I guess I'll just sneak it kind of up here. Range, again, this would normally be y is less than 1,250, but since we can't have any negatives, we would say that 0 is less than equal to y is less than equal to 1,250. And that would be our range of the situation too. So a nice little word problem using Desmos, of course, right? But tweaking it a little bit because, hey, this is context. Desmos doesn't know the context, so we kind of have to put that in by hand afterwards. Diagram, totally not needed, but here's some cool things that we can do on this question. That'll be it for the first one.